Okay, so good day everyone. Now we are going to talk about complex numbers. Okay, so when we talk about complex numbers, we have also the operations of it. So we have adding, subtracting, multiplying, and dividing complex numbers. So we have some steps, no? Some steps on how to do the following operations in complex numbers. All right. So as you can see here, complex numbers a plus bi. Okay. So in this, we can see here some of the numbers. We have natural or the counting numbers, the whole numbers, integers, rational numbers, real numbers, and irrational numbers. So as you can see that imaginary numbers are, so let me move this one. Okay, so imaginary numbers are outside the box. Okay, not literally outside the box, but as you can see, it's yeah, outside the box. Okay, so what is an imaginary number? So complex numbers are written. Sorry, complex numbers. What is a complex number? So complex numbers are written in the form of a plus bi, where a here it is the real part and b is the imaginary part. So when adding complex numbers, we are going to add, just like in algebra, you're going to add like terms. So here, if you can see the real part, so if you can see real parts, you just combine them together. So that's 3 plus 8. Then the imaginary part, which is 18. So 7i plus 11i. Okay, so apply also the rules that you have learned from our first lesson. Okay, if this is negative, then change the rules. To remove the parentheses, you change the sign inside this one. Okay, just like this. So when subtracting complex numbers, be sure to distribute the subtraction sign, then add the like parts. For example, 5 plus 10i minus 15 minus, then the quantity of 15 minus 2i. So again, imagine that there is 1 here. Just distribute to remove parentheses. So you have 5 plus 10i minus 15. And then negative times negative, that would be positive. So the parentheses will now be removed, and then you can combine the real part, which is 5 minus 15, that's negative 10. Then positive 10 plus 2i, that's plus 12i. So this is now your final answer. Okay, now, with multiplying complex numbers, okay, again, just the same sa inyong previous lesson, just distribute, okay? Distribute this one. So the FOIL method, the first out in last. So first terms are this one and this one. 3 times 5. So you have 15. Then 3 times 7i. That's plus 21i. Then negative 8i times 5. That's negative 40i. Then negative 8i times 7i. That's 56i squared. Negative 56i squared. So class, remember that I squared is equivalent to negative 1. Okay? Because all right, I is equal to the square root of 1. I equals the square root of negative 1 rather. Okay? Therefore, I squared. So you square both sides here. So I squared will now be the square root, or sorry, I squared will now be, if you square mo si square root of negative 1, then ma-remove ang square root. So you will have negative 1 as the value of your I squared. Okay? All right. So simplifying this expression, you will have 15 plus 56, since negative 1 times negative 56, that's positive 56. Then add the real numbers and then retain 9 minus 99. Now this is your final answer. All right, for dividing the complex numbers. Okay, don't worry. I will explain this, or I will have more examples. One example each um, operations for you to understand more. Okay, now for dividing complex numbers, you're going to multiply the numerator and denominator by the complex conjugate. Now, what is conjugate? Si conjugate, diba, is ang the kabaliktaran of the denominator, or yeah, that's 3 plus 5. I just changed the sign of this one, right? That's the conjugate. So multiply the numerator and denominator by the complex conjugate of the complex number in the denominator of the fraction. Let's say you have 7 plus 2i over 3 minus 5i, or divided by 3 minus 5i. So multiply it with the complex conjugate. Okay. Actually, it's called complex conjugate because we are talking about complex numbers. But if you are talking about um, rational expressions, right? So rational expressions are already presented to you as well. So in rational expressions, you call it conjugate. Here you call it complex conjugate. All right. So same thing that what we did. So just simply use FOIL method here. So 7 plus 2i times 3 plus 5i. So you will have this term here on the numerator. Then 3 minus 5i times 3 plus 5i. Remember that this is difference of two squares. So meaning this will just be equivalent to 9 minus 25i squared, because this one will be cancelled, right? Mawawala na siya. So what's left here is the 9 minus 25i squared. So basically I squared is just equal to negative 1. Okay, then what will happen here is negative 1 times negative 25. That would be 9 plus 25, correct? Okay, therefore, this would be 21 minus 10, that's 11, plus 41i over 9 plus 25, that is 34. Okay, so all right, let's have more examples. I will open whiteboard here in my laptop. Hold on. All right, so here you go. Now we have already opened whiteboard. So let's have some examples for plus, minus, times, and divide. So for example, you have 2 minus 3i plus 6 plus 2i. All right, so we just simply say 2 minus 3i, now remove parenthesis, plus 6 plus 2i. Therefore, you can have 2 plus 6, that is 8. Then negative 3 plus 2, that's negative I. All right. So put it, okay, remember always in your first exam, put it in a form A plus BI if it's instructed. Okay. All right. So another example for minus. Let's say 4 plus 2i squared minus I minus 3i plus 2. All right. So once again, I squared, once again, I is equal to the square root of negative 1. Yeah. So that's why it's called imaginary, because because there's no such thing. Okay, that's why it's called imaginary. So the square root of negative 1 is imaginary. So if we square both sides, this was what I explained earlier, no? So you can have I squared is equal to negative 1. Therefore, this right here would be equal to 2 times negative 1 minus I minus 3I minus 2. Okay, so that's 4 minus 2, since this is negative 2, right? Minus I minus 3I minus 2. Okay, so combine all the real terms. So 4 minus 2, that's 2, minus 2, that's 0. Okay, what's left is negative I minus 3I. So you can have your answer as negative 4I. And this is your final answer. Okay, so for what do you call this? Now let's have the multiplication. 3 plus 2i. Okay, multiply it by 4 minus I. All right, FOIL method first is 12 minus 3i plus 8i minus 2i squared. Okay, automatically this is negative 1. So negative 1 times 2, that is, sorry, negative 1 times negative 2, that is positive 2. So therefore, plus 8i plus 2. Okay, so combine the real numbers. So 12 plus 2, that's 14. Then negative 3i plus 8i, that's plus 5i. Okay, so again, this is in the form of a plus bi, so this is correct. Okay, all right. Lastly, for the division of complex numbers. For example, you have 6 minus 5i over 2 plus I. So again, get the complex conjugate of the denominator. So that's 2 minus I. Just change the sign over 2 minus I. Okay? So therefore, you have this one as 12 minus 6i. This is minus 10i. Then this is plus 10i squared. All right. All over, this one is again difference of 2 squared, so that's 4 minus I squared. Okay. So once again, I squared is equal to negative 1, so this would now be 4 plus 1. That is equal to 5, right? So this one here is 12 minus 6i minus 10i minus 10. Okay. So I squared is negative 1 times 10, that's minus 10. All over 4 minus negative 1, that is 5. Okay. Combine real terms, you will have 12 minus 10, that's 2. Okay, 2 minus 16i over 5. Okay, so if we change it to the form of a plus bi, so you can have 2/5 minus 16 over 5i. Now this is your final answer. All right, so if you have questions, guys, do not hesitate to ask me. I am free whenever you want to ask, but yeah, just let me have some time now to see your messages. So thank you so much for having this lesson with me. Yeah, I will give you activity, but you do not need to answer. So just try in your notes, no, try in your notebooks. Number one is 4 plus 2i times 3 minus I. Okay, number 2 is 6i plus 6i squared minus 2i plus 4. All right. Number 3 is okay. Mm, um 4i squared over I minus 2. And then number 4, let's say 6i times 8i squared minus I all over 6 minus I. All right. So just try to solve this one because I know most of you have a lot of work to do in your other subjects. But if you want to know more, then practice solving these equations right here or the expressions right here. Okay. So see you on Monday. Thank you, everyone. Have fun.